Hello everyone, welcome back. So this time in Stacks we're going to be learning about something called a moment. Now what is a moment? Well, we're going to find out in a moment. Okay, I couldn't, that was just, it was there, I had to take it. So what is a moment? Well, before we get into that, let's talk about some applications. First off, you have a little bolt right here you're trying to put in, and you are applying force on this socket wrench. Why do you grip it by the end of the handle instead of somewhere closer? Is it better for it to be at an angle, or would it be better for it to be kind of like straight out? How do we tell? Well, we'll have to figure that out. An application would be this right here. We have a bracket that is holding this along the slide right here, and we are applying a force that's trying to turn it. Now this bracket can hold it in place, but how much force can you apply before that bracket breaks? How do you know? Well, how we figure this out is we calculate the moment. Now, what is a moment? It is the twisting action that you're causing. It is the tendency to twist. So the longer your lever arm and the more force you apply, the more something wants to twist. That's actually why if you look in old vehicles, you see they have extremely large, extremely large driving wheels. They had those because they didn't have power steering back then, and so they had to have a really strong moment to be able to turn the wheels. Now you could have a tiny little steering wheel because power steering does all the work for you. So moment is force times distance. Force times distance, but more than that, it's force times the perpendicular distance. So that distance we're calculating right here, that is the distance to the force's line of action. That means that if I have my force right here, and I draw some, infinite line going both directions, and I have some point right here that I'm trying to turn it around, well then I drag a line straight to this line of action, not to where the force is, but to its line of action, so that it's a right angle. That is the distance, okay? If my force was up here, this would not be the distance, okay? That is not the distance. It would still be this because I go to the line of action. Okay, so how do we actually calculate this? Well, if we don't have something super nice where you're like, oh, it's just so easy to figure out, because this, the distance and the force are all perpendicular to each other. Well, we can break it into components, okay? That's the easiest way to think about it. Just break it up into components. So, right here you see we have a force going straight up. And we have some position right here, vector right here. Now, if I'm thinking about it, if I'm turning around this wheel, then I need to make sure that my position vector is only in the x direction. So it isn't just the position vector r, it's r cosine of theta. R cosine of theta. Now, technically, I could have a second component here, but since it's going only around this point, don't really have to worry about that. Now, if I take the cross product, I get the total moment, but if I only want the component that is around this axis, then I only need those two components. Now notice something here. I have an x distance, I have a z force, and I get a y moment. It's because it's a cross product. You're going to get the thing that you didn't include. X cross z is equal to negative y. It's actually negative x cross z, so it's equal to y. So don't forget that, okay? That's the important thing to notice here. Another thing is you can just break it up into components. So if you've got a force, it has an x component, and it has a y component. Same thing with your position vector. It has an x component and a y component. And you just multiply the two together and then add them or subtract them based on the direction. So I hope this helps you. If it hasn't quite stuck yet, we're going to do some example problems. So don't worry about that. Just wait till then. Walk through an example or two with me, and I'm sure that you will get it very quickly. Well, I'll see all of you next time, and I hope you have a wonderful day. Bye-bye.